Hey everybody, this is Mr. Munson and we are in Foundations. This is G.0 unit, right? And so this video is going to cover concept number 2, which is adding segments and angles. But we're going to first talk and remind ourselves some basic geometry. Let's go ahead and get started. Okay, first of all, in case you haven't drawn a line underneath your last summary, go ahead and draw that line. Go ahead and write the title of this unit, and it's G.0.2. There's an extra dot there. Segment and angle addition. Very basic stuff. It makes total sense. It's going to be quite easy to some of you, but I want you to know if you struggle a little bit with this, it's probably going to be just a matter of you experiencing the material and understanding it. So don't give up. Just push through, ask questions. I promise you, you will find this to be extremely easy once it clicks for you. You just got to ask questions, okay? All right, well, let's start with that basic geometry stuff first. And so take a look at this yellow box over here. And what I want you to do is recognize that it has different sides to it. And as I'm outlining in blue, what my mind's eye sees is kind of the front panel of this rectangular prism. Okay, there's 6 sides to this thing. That's one of them. Okay, now on that panel, I could find lots of points. Points are throughout it. There's one on that panel right there. There's going to be one we'll just put right there. There's one on this corner over here. There's an infinite number of these points. Okay, so what I want you to know is that points are, there's no real definition for it. I can kind of describe what a point is, but it's not a definition. There's going to be 3 words this entire year where we're not going to define them. We're just going to assume you know exactly what they are conceptually. So one of them is a point. And so points are basically a location, someplace in our world. Now, we have special notation that we use for points. Points are just simply a single capital letter. All right, so I'm going to call this point A, and we'll call this point over here B, and this one I'll just call C, and this one K. Now, I've randomly picked those. There's no reason, rhyme, or whatever to it. You can even see, you know, maybe it made more sense to go A, B, C across the top of the blue line. But it doesn't matter. So here's my points. And so when I go to write, if I want to refer to point A, the notation that I would use is I'd put down a dot and then a letter next to it. That's point A. This is point B, this thing right over here. Okay? Single letter, capital. That's all you need to know. So what's a line? So again, a line is undefined. I got to just assume you know what a line is, and there's an infinite number of lines. And this one, in this particular case, I'm going to line up to go through the points A, C, and B. Okay? So what is a line? A line is just an infinite number of points that all kind of line up in a straight line. But to define it, to say what it is, I have to still use the word line, and that kind of indicates you know what I'm talking about. So what's the notation for a line? The notation is you're going to grab 2 points that are on the line, I'll say A, B, write them down, and then you just draw a line above them. Okay? So that represents the line AB. Now the exact same line here is AC. It goes through AB, but I could grab any 2 points along that line. Here's another line. And it goes through the points C and K. So that particular line is CK with a line above it. Okay, cool? Let's move on to plane. Okay, a plane is undefined as well. We have an idea what it is. It's basically a flat surface. And so I can write down the notation. If I wanted you to look at that flat front panel, I could certainly say, hey, look at the front of this box. But more, you know, mathematically, I would pick 3 points on that plane and write them down. So the thing is that the 3 points that I choose can't all lie in the same line. So I couldn't choose A, C, and B. But I could choose the points A, C, and K. And the reader should know I'm talking about this plane, the one that's in the front, and not the plane in the top, because K is not on the top. Now, in addition, I'm going to draw kind of a sideways, what we call uh, looks like a rhombus. We'll learn about that, kind of a square leaning over. And so that represents, in words, the plane ACK. Now, very commonly, there'll be a letter down in a corner, let's say like that, where there's no point associated with it. And so that's another way of getting you to understand. I want you to go and look at, let's say, plane W. Let's put a R up in the top one. So I would say plane R. It's that simple. Let's move on. Okay, great. So now let's take a look at the first real big topic that we want to cover in this foundation or in this video. It is segment addition postulate. Now the word postulate is probably brand new to you. Postulate just means statement. It's a statement of truth. It's just something that we have to all assume is true. I don't have to prove it or anything like that. And here's what the segment addition postulate says. You can add segments together and to get bigger segments. It's that easy. So if you look at segment AB here, right, I can take segment AB and add it to segment BC. Oops, there it is. BC, and I can get the bigger segment AC, right? So this length here of AB plus the length of BC should give me the length of AC. And so in an equation form, I hope this totally makes sense. Put me on pause and just analyze that equation and compare it to the picture and see it does make sense. All right, so now let's take that topic and apply it to a problem. So we're going to be writing a lot of equations, and I'm going to be helping your brain develop its ability to logically reason through things. And we're going to use writing equations, ideas about segments and about angles and triangles to help strengthen that part of your brain. Here's the first case. So I have this long segment AC. It's broken up into two parts: a small segment called AB and another segment called BC. Okay, so now it just might be picture-wise. I'm not sure if it's really drawn to scale or not. It doesn't matter. The fact is, the length from A to B, the distance from A to B is 20 miles, 20 inches, whatever. The distance from B to C is 4x. So what if I find out what x is, I could multiply times 4, and that'll tell me how long BC is. Now, those two lengths together give me a length of 12x plus 4, something that doesn't look anything like the 20 and the 4x. But what I do know is that those two things added together, 20 plus 4x, better equal the full length of the segment. All right, what I want you to do is I want you to go ahead and solve that equation for x. Go ahead and put me on pause and do that. Okay, if you're like me, I got x equals 2. Now here's the thing. We wrote an equation and found x. I could have asked you the question, hey, find the length of BC. Now I look up at BC and it's 4x. For me to find the length of BC, I would need to know logically, oh, I got to write an equation, solve x, and then what I would do is take that x and I would plug it in for that 4. And so in this case, I find that BC is 8. Now, indeed, it proves right there. If that's 8, this drawing is not drawn to scale, but no worries. This is the problem, okay? So if I want to know what AC is, that's the distance from A to C, I can just plug it into the expression for that one. Or I could simply now just add the 20 from AB to the 8 BC, and I get 28. Let's see what happens. If I plug the 2 in here, I get 24. Plus 4 is 28. Same thing, either way. Very good. Let's move on. Now, I'm just going to shrink down my notes here to get some spacing for the next problem. All right, there's the next problem. Do like I just did in the model. I first started by writing an equation, then I solved for x. Go ahead and do that. Put me on pause, and then come back and check your work. Okay, that's the equation I wrote. If you did not write that equation, then what you want to do is put me on pause and go back and watch my model. that I just did a few minutes ago and see why you wrote something different. Because this one makes logical sense. This piece plus this piece should equal the entire thing. So now I got x equals 3. Now I could have wrote in the directions, instead of just saying try it, I could have said find AC. Now notice that there's no bar above AC, like segment AC. If I ask you to find segment AC, then I would put a bar above that, but that wouldn't make sense. What I want you to know is when there's no bar, this means the measure of the segment AC, okay? All right, you'll see more and more of that and get used to it as we go. Now, I'm getting ready to flip the page, so if you want to put me on pause and write down your notes, that's great. Hopefully you're not writing while I'm talking. The other thing is that know that at the end of this video, there's going to be some do-it problems, and they're based on the problems that we're doing in the video. So if right now you're confused, you don't go any further. You just simply back up in the video and listen a little bit more intensely. For some of you, maybe it means putting your phone completely away from you, turn it upside down, ringer off, and all those things. Tell the dog stop coming in. Tell mom to stop bothering you about dinner and everything. And it's just focusing in on what I'm telling you. This is going to be the year that you're going to do well in math. Okay, now let's talk about special case where we're adding segments together. I have the segment A, B, C here, or just the segment AC. I only need 2 points to name it. What I've been told is that B is in the center. It's actually right in the middle. So a way of saying that is the word midpoint. So in your notes there, just write down midpoint is basically a point that's in the middle of a segment. Now, PT for me stands for point. I apologize if that caused you any distraction, but it just saves us some time. So using that, what ends up happening is when something's in the middle, that means if the length between A, B is 5, then that exact same length belongs to BC. If this was the whole thing, let's say the whole thing, AC, was 12, from A all the way over to C was 12, then I know evenly half of it's one place, half is in another place. Now let's just real quickly talk about how I can mark those two segments the same length. Not having numbers on them, I can just take little bars like that, and they're slanted, and I can put it there like that. And that tells the reader those two things are exactly the same length. It's the same thing of saying, hey, B's in the midpoint. Now, I could use 2 marks if I want to. They just have to match up and be the same. All right, now let's take a look at the example problem down here at the bottom. So I'm told that by those marks that AB and BC are the same length. I could say B is the midpoint. Either way is going to tell you the same thing. But I'm told that the distance from AB is 3x plus 6, and the distance from BC is 4x minus 4. Now, those expressions don't look the same, but what I'm telling you is that they are the same. So what I'm going to go do is try to find an x that when I plug it into the left and plug it into the right, it actually generates the exact same number. So what I know is that AB is the same as BC. So from an equation point of view, this is what it means. 3x plus 6 equals 4x minus 4. And of course what that says is that once I solve for that and I get x equals 10, then when I plug it back in, the two pieces should be the same. Let's just double check that. X times 3 is 30, that's 36. So when I plug it in on the other side, I better get 36. I sure do. 4 times x is 40, 40 minus 4 is 36. Fantastic. Let's move to the other side. All right, we're going to add into this the angle addition postulate. Super easy. It just basically says if I have 2 angles who lay next to each other, they have kind of the same wall. Here's a wall that they share, right? These 2 angles. When they lay next to each other like this and have the same wall, basically I can add their measures together and get a bigger angle, right? Okay, you can add smaller angles to get larger angles. So if you think about it, I have this one angle. We'll call this A, B, C. This angle right here, I'm calling A, B, C. You can see it's written right here. That added to this other angle, CBD, and I'm just following the letters with B being the vertex, right? The middle point. Then that all added together better equal whatever that big angle is called ABD. Okay? And that's that part right there. I can add angles together to get larger angles. Now let's take a look at our problem. So I have these two angles like this. The information that tells me PST, the angle PST, has 76 degrees to it. Let's mark that in the drawing. Now take a look at that. Just put me on pause and make sure you understand that that's PST. If you read PST and didn't know that that was that angle right there, you need to analyze that. Put me on pause and make sure you'd understand that that is angle. Now the next information says RST is 146. Let's mark that. There's angle RST right there in blue. So let's mark that. Let's see, I'm just going to draw a big arc like that, put an arrow on it, and that represents 146 degrees. Okay? Now, RSP, which is this angle right here, that's the angle what they want me to find. If you don't mind, I'm just going to call it X. Now let's write an equation. And there you have it. The two smaller angles, one is X, the other one's 76, add together to give 146. I'm going to trust at this point you know how to solve that. You know how to solve for X. And that will tell us what that angle is, which is what the question was. All right, here's your do it problems. Make sure you put the title at the top and your name and date, okay? Now this is a kind of a long video. We're at almost 17 minutes. It's 2 minutes longer than what I want. I want the videos between 10 and 15. But as we're at the beginning here, we're going to spend a lot of time kind of going over a lot of words and things like that. So stay with me. Just trust. We're going to be looking at videos between 10 and 15 minutes, and they won't usually be this long. Now I'm going to zoom in on the problem, so if you're on a small device, you can see this a little bit better, but you're going to copy all this information, right? You're going to copy the information down. Do one problem at a time. Copy the problem down, do the problem. Copy the problem down, do the problem. Copy the problem down, do the problem. Don't forget to circle your answer and show all your work. I wrote equations. I expect you to write equations. I showed my work. I expect you to show your work. All right, let me zoom in, and that'll be it. And I'll just scroll through the problems so you can see them. You put it on pause when you need to. And there you have it. Have a fantastic day.